In this video, we're going to be talking about how to solve linear systems using the graphing method. So when we talk about a graphical method for systems of equations, what we're really talking about is graphing both equations and then finding a point of intersection. So for example, let's try solving this system graphically. Now before we start, I should note that you could solve this with substitution as well. And so you may be thinking, well, why would you care about a graphical solution? Well, you can learn a lot from a graphical solution that you can't from a substitution. Substitution pretty much just tells you how to get an answer, whereas the point of intersection actually gives you insights into what's actually going on. So for example, what's happening here is we have two equations which are 1/2 x plus 3y equals 1. If we write that in slope-intercept form, we would need to solve out for y, which would be y, so we'd have 3y equals negative 1/2 x plus 1. Divide everything by 3, so you have y equals negative 1/6 x plus 1/3. Similarly, if I solve out this equation for y, and this one's a little bit easier, we have x minus y equals 2, so negative y equals 2 minus x. But then I'm going to multiply everything by a negative 1, so I have y equals x minus 2. So if I graph both of these equations, what do I have? Well, let's go ahead and set up our coordinates. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2. So if we set this up, what we end up with is this is just the line that goes through negative 2 y-intercept as its y-intercept with a slope of 1. So up 1 over 1, up 1 over 1, and so on. So like that. This has a y-intercept at 1/3, which is about there. And to go down 1/3, what you would have is you would be going down 1/3 whenever you had x equal to 2. And so you end up there. So if you graph like this, you see that this is the point of intersection. Namely, the solution to the system is going to be 2, 0, because that is the point. This also helps explain why we use ordered pairs instead of using instead of just saying x equals 2 and y equals 0. Is because the ordered pair reminds us that there's some graphical solution going on. And now it's once again time for you to try out an example. So go ahead and solve the following system graphically. On the count of 3, I will reveal the solution. 1, 2, 3. So here you see that when you solve out into y-intercept into slope-intercept form, for both of these equations, you end up with these, and then you go ahead and you sketch them both out. When you sketch out both those lines, they intersect at 2, 2, so that is in fact our solution to the system. So for more practice in solving linear systems graphically, you can see section 7.1 of the textbook, pages 475 and 476, and work exercises 2 and 33 through 36. In our next video, we'll be talking about some applications of linear systems.